quite a bit of equipment. And a bottle of water. Okay, JavaScript, all the things. My slides are not that pretty, but yeah, it's all in the spirit of the maker movement. Hardware hacking, have fun while avoiding your warranty. Basically, David introduced me already, so I'm actually going to take this opportunity to teach the world how to pronounce my name, because for the past 10, 13 years, it has haunted me that it's always mispronounced. So I'm Gilles, not Giles, or something like that, like in the Formula 1 driver from the 70s, Gilles Villeneuve, or for the locals here, if you take the first syllable of ginger and add an L, you have my name, Gilles. So we finally got that out of the way. But yeah, enough of that. I'm basically talking similar to Rachel, Node.js, and I'm using the Parrot drone here, the Arduino, and a little bit of the Leap Motion as well to show you some simple hacking that I've done. And the point, similar to Rachel's, is like, this is really simple stuff. You can really get started quite simply. And here are a few of the projects I've done. You see, one of them is actually quite similar to Rachel's, but not as pretty as hers. But that's not done yet, so it's actually good. We don't overlap. But the other one is like a PS3-style remote control, as this, which I built because I didn't have a PS3 controller lying around. So I built one with an Arduino. So, but to show you how easy this is, I just want to tell you quickly how I got started, because I have no clue about electronics, and I still don't really have a clue about electronics. And it's literally just a year ago when the first Nodecopter event happened in Berlin. It's pretty much exactly 1 year, and that was the first time I did any hardware hacking at all. And shortly afterwards, in Node Dublin, Emily Rose was there, and together with Max Ogden, she took a fog machine and a couple of volunteers, and yeah, you can see the experiment didn't really go according to plan. They actually had to cut off the fire alarm to avoid the sprinklers going off. They nearly had to evacuate the whole building. The floor manager was slightly upset. But I was just amazed like what he could do, and I bought an Arduino at the conference, like on the internet quickly, and yeah, got started. But let's have a very quick look at the different things I'm looking at now. So one is the Parrot drone. Quite a few of you have by now heard about it or bought one and have been at an event. But yeah, it's basically a flying Linux computer. It runs BusyBox. You connect to it via Wi-Fi. You can telnet into it. It has an open protocol that Parrot publishes in its SDK. The commands are sent via UDP, and yeah, Felix, I don't know whether he's around or not, but yeah, he's written a high-level JavaScript client for it. It's really easy to use. And the very important thing, it's fully repairable. You can buy each single part separately, and you will crash it if you hack with it. And even more so, if this guy, Chris Williams, is in the room, and he happens to have a Nerf gun in his hand, that very often results in this, which actually happened to my drone a couple of weeks back, and yeah, that one is actually still broken, so this is a replacement. And I just want to show you a slide of how easy it is to fly this drone via JavaScript. So you just npm install Felix's module, and then you create a client. Here we create a REPL, and we have the takeoff command as part of the script. And then on the command line, we just execute that. And then we can type in the commands. Turn clockwise, or land, or go forward, backwards, left, right. Really, really straightforward. There's also a lower level API to help you build up the UDP commands directly. But yeah, you can dive into that yourself if you want to. So here, who here has heard of Arduino? Quite a few, I think. Yeah, that's quite a lot. So I'm just doing a very, very tiny overview for those who haven't. It's an open source electronics prototyping platform that's targeted at hobbyists, designers, and artists, really. And it's really easy to use. Usually it uses the Arduino programming language that's C-style and based on wiring, but obviously we're using JavaScript. And it's great because there's no really prerequisite knowledge of electronic necessary. And there's some really great beginner kits, such as the Arduino Starter Kit and the SparkFun Inventors Kit. They're around 90 to 100 euros. And these days, I really recommend the Arduino Starter Kit. It's really good, comes with a big book, so you can actually learn from scratch everything. And they explain the basics really well. And yeah, a little bit of duplication here, but Rick Waldron last year, he's one of the jQuery core contributors. He developed Johnny-Five. And Johnny-Five, it's actually the robot from the 80s movie Short Circuit. It's a high-level library that really makes it as easy as programming JavaScript, jQuery animation. So, very quick example. So again, you install it with npm, and then you create a new Arduino board. And once the board is ready, so board on ready, it's pretty much document on ready, you know, for your Arduino. You create a new LED and you strobe it. That's the hello world of Arduino programming, there in like 5-6 lines of code. If you compare that to what it looks like in Arduino language, it's not complex, but you have this setup method, you need to know what the pin modes are, and you read this and you have no real clue what's going on. And I think an important difference is really, it's very procedural, and you constantly send or poll for data compared to when you use Johnny-Five, you use objects and event emitters. For example, a potentiometer, when you change it, it fires a change event with a new value. So that's as easy as it is. So I built this little PS3 controller, style controller. I didn't have one lying around. I'm not really a gamer. So I built one. And this is the diagram I made with Fritzing, which is an open source tool that allows you to create electronic diagrams without knowing anything, how to write real electronic diagrams. So, and you can see it's very easy. It has 2 joysticks, 3 resistors, a button, and a few cables. That's all there is to it. So, yeah, let's try this now. So this will take a moment. And I think I'm going to need a little bit more light in the room, otherwise the drone will get very confused. Okay, so. Nobody connect to my drone, please. Okay. So you see, I'm just connecting via Wi-Fi. Okay, and there you see Johnny-Five initializing the board, and this should work now. And yeah, that's it. So let's have a little bit of a look at the code. Let me just zoom in. I think this is probably going to do the trick. So the code is actually, you see, it's 144 lines of code. It's really not a lot. And this is just checking the different animations you can send to the drone. And then here is actually the crux of it all. So we have this remote constructor that inherits from event emitter. Here we just set up, so if you can build this, all the code is on NPM and on GitHub, and it comes with the schema as well. So you can build it, but if you want to wire it up differently, you can override these, you can send different animations if you want to. And then we set up our different buttons. So the takeoff and land button, and then the buttons on the joysticks themselves. And then we just have 4 sensors for up, down, turning, front, back, and left, right. And you have to think of a joystick as 2 sensors, one on the x-axis and one on the y-axis. So there's also a joystick object, but when I wrote this, you could only have 1 instance going on, which was really weird when it didn't work. So that's one thing to bear in mind when you hack on these things. It's still very often developer preview code. So yeah. And here we just set up our commands, and you see, we just emit the commands. Here we get our handlers, so that's all the same, that's just configuration code really. And here is actually our get handler, so it's basically If we have an error, we don't do anything. And I guess this is the most important line of the whole script, normalized value, because the joystick has a minimum value of 0 and a maximum value of 1024 and a resting value of around 512. So we need to basically put that into speed for the drone between the values of 0 and 1. So second of all, it's like a joystick in a resting position. I said it's 512, but actually that's a lie. It's actually varying, fluctuating all the time. So you have to basically put some code in that checks like, okay, is it between these values? We just assume that's the middle kind of thing. And then it sends the commands. Here's some boilerplate code to do the animation stuff. And yeah, so there is similar and is middle. So those are the ones that are important, really. So you see, is middle, as long as my value is between 450 and 573, I just assume it's in a resting position. And that's it. And here we scale it, and that's all there is to it. In the example, to hook it all up, you pull things in. I overwrite the takeoff command to always disable the emergency, so if you crash, that you don't have to power the drone on and off. And then I have the commands. You iterate over them. So usually I do it like this, but I thought it would be good to see in the console the values that I actually sent. And that's all there is to it. So altogether, not even 200 lines of code, and you have your own remote control. So let's get back to this. Actually, I have to do out of mirroring mode. Get confused. Yay! Cool. Okay, the next thing I fiddle with is the leap motion. So the leap motion, lots of you have seen it. It's a USB device with 2 monochromatic infrared cameras and 3 infrared LEDs. And it processes, it takes about images 300 frames per second, and then it says on Wikipedia, it applies complex math, also known as magic, to this, and that helps you track the fingers and hands and pens. You can even have a pen, and it sends that information to the SDK, and you have SDKs in JavaScript, C#, Java, Python, and yeah, so you see this, and you're like, wow, I'm going to be like Tom Cruise, Minority Report, waving my hands around, or maybe Tony Stark, like talking with Jarvis, but the reality is actually more like this. So controlling your computer is actually quite frustrating with it. So, but I was like, what about controlling robots with it, you know? So, and I actually thought I was the first. I was very naive because I pre-ordered it and I got it on the day of release, but yeah, I wasn't really aware of the developer. There was a developer version that's been out for a year or something like that, and I think Andrew had seen loads of people already doing it at different Nodecopter events. And when I finished it at the Nodecopter event in Berlin a couple of weeks ago, there was actually another team doing exactly the same thing. So, and actually on Monday, Andrew tweeted this, and there was actually a team who won $5,000 just on Monday or over the weekend for controlling the drone with the leap motion. I should have gone to that event. But so let's try that as well now. I need to switch a few things over. This is going to get a little bit more dangerous because controlling the leap motion is shaky in the first place, and I'm a little bit shaky when I'm presenting, so if the drone comes towards you, either duck or take it like this and turn it around. That will kill it, basically. So I don't know whether there's insurance, so no insurance. Okay, so even more difficult. Damn. So let me actually. No, that's wrong button. No, it's actually, sorry, that's like this. Okay, and I had this actually together with a module written by Laurent. So hopefully, yeah, cool. Cool, okay, so. Ah! It's confused! Let's give it one more go, because there's one gesture which would be lovely if we could get it working. So let's just try. Okay, and so cool. That's that. And you see, I still have a problem with an event emitter. I need to sort. Still very much an alpha release, 0.0. So, okay. So let's have a look at the code here. So the whole camera thing, that's actually a completely different module written by Laurent. I can't remember, Ed Ashnu, he's on Twitter. And so I just had to hack my things in there, and it just worked perfectly. He also has a plugin system for it. So, and, okay, good. So similar thing, this is actually 182 lines instead of 140, so it's slightly more complex. But yeah, so Leap Motion, they actually released a module to control the Leap Motion, or to get the commands, the data from the Leap Motion that you can just install with npm install, and then we do similar things. So rather than starting a new Arduino board, we create a new Leap controller, and then on each frame, we call the process frame. So, and this is basically the heart of the whole thing. The dispatcher is like a router kind of thing. So it's like if the frame is not valid, we return basically 404. If we detect a circle gesture, we check which way the gesture goes and whether we should take off or land. So that's basically going one way or the other. Don't fly away. And then we look at the hands. And for example, the punch is, the logic is like you have to have two hands, and if one has a velocity is moving at a faster rate than a certain value, we animate with a flip, basically. If we don't have a hand, we hover, so that's why you saw me pulling my hands back in panic. And I'm also calibrating the drone, so every time you put your hand over, it takes about 1 second for it to get the value. So if you take your hand back and put it down at a lower level, it will just recalibrate this as a new middle value. And then it just sends every frame. If all those conditions are okay, we send these commands to the individual event emit things. So, and again, so here's the calibration. Here's rechecking the gesture, and so on. You can look at this in more detail, the hovering, and here are just a different, very similar to the other one. So I can actually partially apply this at some point. But yeah, we're scaling the values similar to the other thing, and that's really it. Again, most important thing is the scaling and a similar function. Okay, so first this. Let's see. Okay, we did that. Okay, gotchas. Just a few things like that I had to learn a little bit the hard way. Debugging can actually be hard, because especially when you're starting out with this, it's like you're new to electronics. You don't know, is my circuit completely wrong, or is it faulty hardware? Is my code maybe a little bit dodgy? You can't really use a debugger. You have to log values and use multimeters and LEDs to debug the hardware. So it's basically you have to debug a real-time system, and that can be hard. Another thing is physical components are not perfect. I was really naive when I first connected the joystick. I read like, okay, 512 is the middle value. Okay, if not 512, then do this and that. And yeah, the thing went all crazy, and I think I destroyed a drone as well like that. But yeah, so be tolerant, like have a similar function. I think I have in every project I'm doing with hardware, I have a function like that. Properties can change depending on circumstances. Actually, from the previous point, the physical component is like you press a button and you would think you can just read the value of the button, whether it's on or off now, but actually you have to wait for about 100 to 300 milliseconds because the value is bouncing between on and off for a while. So things to keep in mind. Yeah, properties can change depending on circumstance. The hotter an environment gets, the lower the resistance, if I don't get this the wrong way around. Yeah. So is it the other way around? Yeah, sorry. Thank you. So you see, I'm still not good at this. Yeah, and cheap components can really make your life miserable. I once spent 2 hours wondering why my thing didn't work, and it was just actually that pin on the breadboard. So a couple of years can sometimes cost you much more. So, get started. Yeah, the barrier to entry is lower than ever. There's more and more information out there, and the prices are getting more and more affordable. It's still not ridiculously cheap, but we're not talking thousands of euros anymore. You can use the tools you know, JavaScript, and learn new skills, debugging real-time systems, reverse engineering protocols. You're probably forced to read more code because lots of the modules are not documented that well, like including my own. So you just have to read to see what's going on there, which is a good thing always. Start a community around it, like the whole Notebots movement going on, and learn about electronics and math. And you might even be able to make a little bit of money. I have a couple of friends of mine in the Arduino user group in Rome. Sarah, she's a creative director, and Eugenio, her boyfriend, is a web developer, and they made this campaign for the Quasar Institute of Rome, where they build these robots with Arduino who protest in front of the Ministry of Education for better technology training in schools, and to inspire a whole new generation of engineers and technologies. And they had signs like more technology, less rhetoric, microchip, macro knowledge, and yeah, really beautiful design as well, I think. And yeah, that's it. And I would just want to finish off with Edwards' law. Any application that can be written in JavaScript will eventually be written in JavaScript. If you're in Rome, join us at the Arduino user group in Rome or Roma JS meetup, which we just started. And that's it from me. Thank you very much.